A single number just changed everything. 35,000 kilograms of thrust. No press conference. No ceremony. Just a specification, buried in a state-backed Chinese engine program's release. And most of the industry moved past it. They shouldn't have, because that number means China is no longer knocking on the door of wide-body engine capability. It's already inside. Here's the mechanism, the one running underneath every fleet order, every long-haul route, every pricing negotiation in global aviation. Engine control creates lock-in. Lock-in creates dependence. Dependence creates leverage. For decades, that leverage kept Western manufacturers, specifically Boeing, in a structural position no one could reach. That structure is now under pressure, not from a test flight, not from a product launch, from a number no one was supposed to notice. The C929 widebody is in detailed design. It has a range, a seat count, a named launch customer. But the aircraft was never the story. The engine is the story. It always was. Because until China controls the engine, it doesn't control the system. Without the system, the C929 is just a very expensive aircraft flying on someone else's terms. The CJ2000 was supposed to fix that. For years, it didn't. Now something has shifted. The question is no longer, can China build it? The question is, what happens to Boeing the day it finally proves it works? Most people think Boeing and Airbus compete by building better planes. That's wrong. The real control point is the engine. It has been for decades. Not because of engineering pride, because of lock-in, the kind that doesn't just bind airlines to manufacturers, but binds the entire structure of commercial aviation into a single dependency chain. Here's how it works. An engine determines fuel burn, range, maintenance intervals, and long-term operating cost. For an airline, those numbers define profit and loss on every route. A 1% fuel efficiency gain compounds into millions across a fleet's lifetime. A reliability problem grounds aircraft, disrupts schedules, and destroys margins no balance sheet absorbs quietly. So when an airline commits to an aircraft, they are not buying a plane. They are buying into an ecosystem. And leaving that ecosystem isn't a technical decision. It's a financial survival question. Service agreements, spare parts contracts, overhaul schedules. The switching cost isn't just money. It's years of retraining, recertification, and operational disruption most carriers cannot absorb without serious bottom-line damage. That's the lock-in. And once an airline is inside it, it doesn't leave. For decades, 3 companies own that lock-in. GE, Rolls-Royce, Safran. They don't just build engines. They set the performance benchmarks. They define what reliable means for every aviation regulator on Earth. They own the certification standards that new entrants must clear, on a timeline those same incumbents effectively control. The lock-in isn't accidental. It was engineered over 50 years. And it defends itself. This is why Boeing's leverage held even as Airbus competed hard on airframes. Both still relied on the same engine ecosystem. Same suppliers. Same certification frameworks. The surface competition was fierce. The foundation was shared. Even competitors reinforced each other's position. So if you want to break that system, not just sell aircraft, but shift power, you need your own engine. One that airlines trust, regulators certify, and operators depend on at scale across years. That's the barrier. Structural, relational, historical. For decades, no one cleared it. Until China decided it had no choice but to try. This didn't start recently. China identified this problem more than 15 years ago. The diagnosis was unambiguous. Without a domestic engine, every aviation program China built would remain strategically incomplete, permanently exposed to foreign decisions, foreign pricing, and foreign leverage over the one component that drives the entire system. In 2009, a dedicated state-backed engine program launched with one objective: remove that exposure entirely. But the gap was larger than anyone wanted to admit. Jet engines operate at the absolute edge of material science. Extreme heat inside the core, extreme pressure through turbine stages, continuous mechanical stress across thousands of flight cycles. And unlike almost any other engineering system, they cannot degrade gracefully. They are expected to perform identically on cycle 10,000 as on cycle 1. Not approximately. Exactly. That's not just an engineering problem. It's a consistency problem, a manufacturing problem, and most critically, a time problem. Because the only way to prove an engine works is to run it. For years, across real operations, under conditions no test cell fully replicates. Western manufacturers didn't build their position in a decade. They built it over 50 years of accumulated flight hours, real failures, and hard refinements no competitor can shortcut. That experience has a name in aviation: confidence. The CJ2000 had none of it. Through the mid-2010s, it appeared at air shows. Performance targets were stated, but the gaps were always there. No confirmed certification path, no independent performance validation, no milestone evidence matching what Western programs show at comparable stages. It looked like progress. It wasn't. And the consequences of that gap aren't abstract. If the CJ2000 fails to mature on schedule, the C929 program stalls. Not a delay, a structural rupture. An aircraft China has committed to, with a launch customer on record, enters a holding pattern with no domestic propulsion solution. Every wide-body it eventually flies would depend on Western engines, Western pricing, Western maintenance contracts. The lock-in China spent 15 years trying to escape would remain intact. Then the target moved anyway. China shifted focus from regional jets to long-haul wide-body, the most demanding, highest-stakes segment in commercial aviation. The engine problem didn't get easier. It got existential. Here's where the pressure became structural. While the engine stalled, the aircraft didn't. The C929 moved into detailed design. Not a concept, a real program with confirmed parameters, long-range specifications, and direct competition with Boeing and Airbus wide-body jets. And then came the move that removed every option for delay. China committed as a launch customer. That changes everything. Once a major carrier commits, the program stops being ambition and becomes obligation. Timelines harden, budgets lock, political visibility rises. Decisions that could have been quietly deferred are now tracked, scrutinized, and expected. From the outside, the C929 looked like momentum. From the inside, it was a trap closing around an engine that wasn't ready. Normal aircraft programs align engine and airframe development precisely because they can't function without each other. Tested together, certified together. The timelines are not separated by design. But here they had split. The airframe was advancing. The engine was lagging. And that gap wasn't just a scheduling problem. It was a leverage problem, playing out in real time, compounding with every month of delay. Every month the engine stayed behind. China's wide-body program remained partially dependent on foreign propulsion, which means the C929 couldn't deliver what the entire program was built for, breaking the lock-in. Without the engine, there is no independence. Just a very expensive aircraft flying on Western terms. Now layer in the structural reason the gap got this wide. The C929 was originally a joint program with Russia, China contributing manufacturing scale, Russia contributing wide-body design experience. The combined capability might have been enough to close the gap faster. Neither partner had to solve the hardest problems alone. Then the partnership collapsed. China moved forward alone. The engine responsibility, the one element that couldn't be divided or deferred, became entirely China's problem to solve. Building a wide-body airframe is hard, but the design paths exist. Building a high-bypass turbofan from scratch is different in kind. It's not about reaching a thrust number in a test cell. It's about sustaining that performance across thousands of operational cycles, managing thermal loads at the physical edge of what materials can survive, maintaining efficiency not over months of controlled testing, but over years of real airline service in conditions no lab environment replicates. This is where programs fail without announcement. Not dramatically, quietly, with delays that compound, timelines that slip, and confidence among potential buyers that erodes before a single aircraft is delivered. The risk isn't that China fails outright. The risk is that the engine takes longer to mature than the program can afford to wait. And right now, that race is still open. Not a test flight, not a delivery ceremony, a specification. In 2025, China's state engine program published a performance figure for the CJ2000, at least 35,000 kilograms of takeoff thrust. For years, the CJ2000 had existed in deliberate ambiguity, referenced, cited in documents, displayed at shows, but never anchored to a verifiable number that could be compared directly against existing engines. That ambiguity was strategic. Unanchored claims can't be challenged. The moment a specific figure was published, the program became measurable, comparable, accountable. This changed that. And the moment it did, two things became clear simultaneously. First, 35,000 kilograms places the CJ2000 firmly in the wide-body engine category. Not approaching it, already in it. China has reached the performance class it spent 15 years trying to enter. That's the lock-in threshold. the level that makes a domestic wide-body program commercially viable, not as a political statement, but as a real product airlines could theoretically buy. That's a threshold crossed. But here's where the second layer appears, and it doesn't resolve cleanly. The engines powering the most demanding wide-body jets, aircraft like the Boeing 777X, operate at significantly higher thrust levels. The gap at the top of the market is real. The highest value, highest margin long-haul routes still require propulsion the CJ2000 cannot yet match. So the old narrative was, China is behind. Full stop. The new reality is sharper and more dangerous for Boeing. Because if the CJ2000 can power mid-range wide-body routes, Chinese airlines can start making fleet decisions that bypass Western engine suppliers before the full performance gap is closed. That's how leverage erosion begins. Not with a direct challenge at the top of the market, with steady displacement at the middle, not sudden, structural. The engine drives lock-in. Lock-in drives leverage. The moment the engine reaches operational maturity, even at current thrust levels, that chain starts to loosen from underneath. That's what the number actually means. Capability confirmed. Performance class entered. But the hardest question isn't in the specification. It's what happens when the engine leaves the test environment and enters the real world. Everyone looks at that thrust figure and concludes the problem is solved. It isn't. Thrust tells you what an engine produces in a controlled test. It tells you nothing about what it does under real load, across real time, in conditions that exist only in actual airline operations. In aviation, the operational record is the only proof that counts. A wide-body engine runs thousands of flight cycles, takeoff, climb, cruise, descent, repeated daily under different weather, loads, and atmospheric conditions. Component by component, it accumulates stress that no bench test can simulate. It has to perform the same on cycle 10,000 as on cycle 1. Not approximately, always. This is where the real gap lives. Not in the specification, in the history, component wear rates, maintenance interval predictability, unscheduled removal frequency, performance retention after 5 years of airline service, not 6 months of controlled testing. These are the numbers airlines buy, and they only exist after years of real operations. Western manufacturers own this ground entirely. GE, Rolls-Royce, and CFM have tens of millions of real flight hours behind their engines. That data surfaces failure modes no test program predicts. It drives refinements that make engines more reliable, more predictable, and cheaper to operate over time. They don't sell thrust, they sell certainty. For an airline committing hundreds of millions per aircraft to a 30-year fleet plan, certainty is non-negotiable. One unexpected grounding cascades instantly. Passengers rerouted, slots lost, investor confidence gone. Multiply that across a fleet, and the exposure becomes existential. No carrier bets a fleet plan on an engine without a track record. The CJ2000 doesn't have one yet. No publicly confirmed certification timeline. No large-scale operational data from real airline service. No visible path through the validation process regulators require before any engine carries commercial passengers. Those aren't administrative gaps. They are the proof. And here's what changes when the proof finally arrives. If the CJ2000 accumulates that record, if it certifies, enters service, and builds the operational history that earns airline confidence, the leverage transfer isn't gradual. It accelerates. Chinese carriers commit. Procurement decisions shift. The dependency chain that has kept Boeing structurally positioned for 50 years begins to unravel from the inside. Boeing's advantage isn't defended by better technology. It's defended by 50 years of trust that took 50 years to build. The moment that trust can be owned elsewhere, it collapses. Here's where it actually stands. China is no longer trying to enter the wide-body engine space. It's in it. The CJ2000 has a declared performance level, a live aircraft program, a committed launch customer, but the hardest part is still unresolved. In aviation, entering the category is the beginning. Surviving it, with enough operational credibility to pull airlines away from a 50-year lock-in, that's the move that decides everything. The real conflict isn't China versus Boeing. It's capability versus maturity. China has proven it can build an engine in the wide-body class. That question is closed. The open question is whether the CJ2000 can accumulate the operational history that makes airlines willing to stake billion-dollar fleet decisions on it. That answer requires time, the one variable this program cannot compress. And if that gap closes, when the CJ2000 earns its operational record at scale, the consequences aren't incremental. Chinese carriers negotiate from independence. Western suppliers lose leverage over the world's fastest-growing aviation market. Every airline dependent on Chinese route access faces a procurement ecosystem that no longer routes through Boeing. The engine drives lock-in. Lock-in drives dependence. Break the first link, the entire chain dissolves. Boeing's position is real today, but it holds only as long as the maturity gap holds. The engine is no longer out of reach. The day it becomes operationally proven, certified, in service, trusted, Boeing doesn't lose a competitor. It loses the reason it was irreplaceable. That's the shift that doesn't reverse.